Okay, so in the last video, we went over like the properties that we use for algebra, all right, like adding stuff together, subtracting stuff, whatever, all this stuff. For today, we're going to be using the ones we look in geometry, right? Um, if you notice, these are in blue because in our, right, even though these are in blue, the ones I underlined in blue, right, reflexive, symmetric, transitive, you can kind of barely see it. They're the same, right? They're the same property, but now we're applying them to geometry as we did to algebra, right? All this stuff over here is like algebra stuff we can do, right? That's what we have like division, right? We have like our division. We also have what it means to be flipped, or actually what a number actually is, all that kind of stuff, right? For geometry, though, it's the same idea, except now we're looking at either angles or we're looking at shapes, line segments, points, whatever you want to call them, right? But really, it's like angles and whatever, all that. Why are we doing all this stuff? Well, because we're going to be talking about proofs, right? So you have what the definition of proof is, but just in case, here it is again. A proof is a convincing argument that you can prove that can prove a mathematical statement, right? You'll see what they are in the examples in class and what they look like, but yeah, we're going to use all these different types of properties and these ideas to prove all this stuff is true, right? And like we're not just like pulling stuff out of thin air and just saying like, look, this is how. There's actually a reason why we can do all this stuff. All right, so the reflexive property. It's just like the reflexive property in algebra. Now it's talking about like angles and segments and all that kind of stuff, right? So again, it is the mirror property. Like as a mirror, what you see is what you get, right? What you see is what you get. There's no if, ands, or buts about it. It doesn't change anything else. So like, I don't know, like line segment. If we have segment, I don't know, JK, that's always going to equal and be congruent to segment JK. Right. It also kind of works the same way with angles too, right? So like if you have angle, I don't know, Q. Angle Q is always going to be congruent to angle Q. All right. It's something to kind of know. You'll see it a lot more with like when we overlap things, what we're looking at. It's kind of useful, but it's not the most craziest one, right? As you can see, right, JK is congruent to JK. It's the same thing, right? It's equal to itself. It's the same thing as itself. Just like how we had um, for the reflexive property in algebra, right? A is equal to A. It's algebra, right? Because it's algebra, there's the equal sign, whereas in geometry we have congruent sign. That's kind of the difference. The symmetric property. Okay, the symmetric property, again, it's the flipped but the same thing, right? You can read it backwards or forwards. It's flipped but the same, right? So kind of like how we had before. If you have, I don't know, line segment BD congruent to line segment PO, then you can also say that PO is congruent to BD. Right? They say the exact same thing, but you can just kind of flip them around. And that also works with angles too. All right. Um, Angle R is congruent to angle T. Then you can say, if you say angle R is congruent to angle T, then say the reverse, angle T is congruent to angle R. All right. So it's the same thing, but you can flip it around back and forth. It'll be helpful. Right? We'll get to it. But also, this unit, we kind of just blow through this part just because it's kind of crazy. All right, lastly is the transitive property. Right. So transitive is that one, it's like the kind of the, like your if-then statements like we did for our, again, our, um, if you give a mouse a cookie type thing. So this one's going to be, it's going to write kind of small just so we can kind of get this done. So let's say that segment AB is congruent to segment EF And if EF is congruent to segment, I don't know, HI, right? So if AB is congruent to EF and EF is congruent to HI, then like again, like we had before, that means AB, this segment is congruent to the beginning, is congruent to the end. Beginning is congruent to the end, AB to HI. Right? You can kind of skip all this in the middle because this kind of works out. And also, right, so if you have angle, I don't know, S is congruent to angle B, and angle B is congruent to angle R, right? Then you can say angle S is congruent to angle R. Alright, so it's kind of a long convoluted way to kind of get rid of the middle as long as it has that self-flow and that same pattern. Alright, but those are the properties of congruence. As you can see, right, all of them have the congruent symbol. They all have the congruent symbol kind of like in every single one because, right, they're a property of congruence like we have up here. So they all have to be congruent. And this has to do with geometry.